So let's talk about functional groups versus molecules, or molecules that have a functional group class. Now, as a Chemistry 2 student, this idea of a functional class may be a new concept, and that's good, you haven't seen it before, but functional groups and molecule classes are two separate things, even though they use the same words. So let's say you draw your Lewis structure on the board. So you draw something that's got an alcohol and a ketone in it. So we've got this molecule here. So this molecule, every organic molecule is composed of individual functional group units. So each unit is basically a link in this entire backbone. So we've got a unit here, unit here, unit here, and there's reason for highlighting these in these different colors, this unit here, and this unit here. Each of those units represents a functional group, and the reason why we like to look at functional groups is that functional groups give us a lot of information very quickly without actually having to draw the Lewis structure. So the way we would write the formula for this molecule would be CH3, because the 3 there, CO for the CO there, CH2, CH2, OH. Now, this entire molecule may have a name associated with it. It may be considered an alcohol or a ketone, depending on the reactivity. And by the rules of organic, we would say that this is an alcohol with a ketone. So why do I bring this up? A common misconception I see with students is that they try to equate the molecule class with a functional group. So each functional group has its own unique intermolecular forces, and it only has one. So in the case of the CH, CH2, CH3s, this is going to be a dispersion force. The ketone, the COO here, is going to have dipole-dipole. The alcohol, the OH here, is going to have hydrogen bonding. So each functional group only has one intermolecular force, but this molecule, this alcohol ketone, actually has all three intermolecular forces present. It has dispersion forces, dipole-dipole, and hydrogen bonding. So to kind of illustrate this point, let's change this here to a CH. And this becomes 1, 2, 3, 4. 1 butyl alcohol. Now, this is an alcohol in terms of what the molecule is, and within this molecule there are two intermolecular forces present. There are the intermolecular forces of dispersion and then the intermolecular forces of hydrogen bonding. But the alcohol functional group is not one butyl alcohol. The alcohol functional group is this OH group here, and this OH only participates in hydrogen bonding. These individual functional groups, the alkyl functional groups, participate purely in dispersion forces. Now, let's say we modified it again. Let's put back our original ketone. And instead of terminating on alcohol, let's terminate on CH3. This would end up being methyl propyl ketone. Now, this ketone molecule contains both dispersion forces and dipole-dipole forces, but the ketone functional group, this CO here, only contains the dipole-dipole, and everything else, these alkyl groups, CH3, CH2, CH2, CH3, contain dispersion forces. Now again, I realize this is kind of a muddy definition. It's kind of like you have two words, but depending on the context, mean different things. That's what you're seeing. But when we talk about a functional group, we're referring to only one unit within a molecule, and it should have only one intermolecular force. If we are referring to a molecule, like an alcohol molecule, or a ketone molecule, or an alkane molecule, this is going to have multiple functional groups which don't necessarily all have the same intermolecular forces. So the molecule as a whole may have multiple intermolecular forces associated. So hopefully this kind of clarifies it for you in terms of distinguishing between the functional groups of the intermolecular forces of a functional group versus the intermolecular forces of a molecule itself.